Hello everybody. I think I'm live. So, review. Test tomorrow. Chapter 3 test tomorrow. And the test is just like the review. So, I'll go slowly, take really good notes. One of the things I'm going to do is try and put some of my work in my notebook. And I'll put some on regular paper. If you want to put it all on notebook, you can. But we're going to see what we get, okay? So, right off the bat, let's take a look at what we have. So, number one, graph each parabola. So what I know is that this is going to be a smiley face way down at -12, but it's going to be 3 times as tall. So alright, let's see if I can do something like that on my graph paper. So I'm going to get my graph paper out. Alright, let's see if I can do this. I got to go way down to -12. I can do that, no problem there. Okay, and draw in my X and Y axis. I got to get down to -12, so I'm going to make sure I have room for that. Okay, and I'm going to start at -12. So I'll go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I know it is 3x squared minus 12. So I'm instead of the 1, 1, I'm going to go 3 times as tall. Instead of 1, 1, I'm going to go 1, 1, 2, 3. Instead of going 2, 4, 1, 2, 3, 4, I'm going to go 3 times as 4, which puts me all the way up here to 12. And of course I'll have the same thing on the other side. So my parabola should look like this. Super skinny, way down at -12. Okay, so right off the bat, the vertex is at 0, -12. And my line of symmetry, my LOS, line of symmetry is at x equals 0. Okay? Pretty good? Alright, and you can always pause this and stop it any time you want. Okay? Number 2. Okay, another parabola. It's going to be upside down because of the negative. We're going to start up at 4 and then go down. Half as tall. Alright, so I kind of know what I'm doing here. I'm going to go ahead and get my X and Y axis in here. And I'm going to go 1, 2, 3, 4. Half as tall. So instead of 1, but I'm going down because it's upside down. 1, 1, I'm going to go 1, 1 half. So I go in 2, 1, 2, 3, 4. I'm going half as tall, so I'll go to 2. So going 3 down to 9, I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. But half of that, so 1, 2, 3, 4 and a half. Now, of course, it has a line of symmetry right down the vertex, which is there. So I have points reflected on the other side of my line of symmetry. There it is. Vertex is at 0, 4, and my line of symmetry is x equals 0. Okay? There it is. So far, so good. Alright, let's look at number 3. Okay, number 3. Let's move this up to here. So what I know about 3 is that it has a vertex, but it's in vertex form. Opposite. Remember, it's got to be the opposite of that, so it's going to be at 3, 4. Remember the opposite inside. Okay, so I'm going to go ahead and number 3, draw this in my little book. I need a vertex at 3, 4, so I'll just try and get my X and Y axis in there. Okay, I'm going to 3, 4. There's my vertex. And I'm going to do my 1, 1, 2, 1, 2, 3, 4. And 9's up 3, 9, 3, 1, 2, 3, 4, 5, 6. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9. And over here at 9, okay? There it is. Vertex is at 3, 4, and my line of symmetry goes right through the vertex. Line of symmetry is at x equals 3. Okay, that's number 3. Alright, 4. Okay, I'm going to shift. I can just keep doing 4. I'll do the whole thing in my notebook. Why not? So it says determine whether it's even or odd or neither. Okay, so what we're going to do is this. There's two ways to do it. One is you can graph it, and the other is just to do the test. So let's go p of x equals x squared plus 2. Okay, we talked about this, maybe about a week ago. So let's see if this works. So I'm going to let the x equal a negative x. Okay, so I'm going to go p of negative x squared plus 2. Now a negative times a negative is a positive, so I get an x squared plus 2. Well, that's the same exact equation that I started with, so it is even. Now, it's one way to do it, okay? The other is to graph it. Luckily, I know how it graphs. I know it starts at 2. I do my 1, 1, 2, 4, and it looks something like this. So since I can reflect this over the y-axis onto itself, again, tells me it is even. Okay, it is even. All right, number 5. All right, number 5 is neither, and I'll show you why. Number 5 is going to be neither, but let me write it down. 5 is a q of x equals a negative 3x squared minus a 5x. Okay, first of all, this is an even exponent, and that's an odd exponent. So it can't be one or the other. It's neither. Plain old neither. Got an even exponent, got an odd exponent, it's neither, okay? Finally, 6, we have a r of x equals an x cubed, you guys can't see that, sorry, an x cubed minus an 8x, 8x to 1. So I have an odd exponent, another odd exponent. That is definitely going to be odd. If you try to graph it, it's a perfect rotation around the origin. Okay. All right, let's move on. So even exponent, all by itself, even. Odd exponents, odd. Combination of both, neither. Okay. That's the easiest way for us for now. All right, number 6. Oops, number 7. That's what I meant to say is 7. I meant to say number 7. Okay, in my journal, 7. So I've got f of x equals a negative. I got an x minus 4. And I have an x plus 5. Okay, all right, now right off the bat, I already have many equations. So if I set it equal to 0, right? Then what I already know is that the zeros are at x equals 4, because the opposite of the mini equation, and x equals negative 5 from the mini equation. Okay, so I'm going to graph those right off the bat. I definitely am. Okay, I'm going to graph that first. Okay, graph that. Graph that. So I know for sure I'm going to have zeros at 4. 1, 2, 3, 4, and at 1, 2, 3, 4, 5. Okay? The vertex has got to be right down in the middle of this. The vertex has to be lying along this line somewhere. Okay, the vertex has to be right smack dab in the middle. So the vertex is 1/2. So if I plug 1/2 into my original equation, I also know it's upside down. I know it's upside down. But let's say I know the vertex line of symmetry is x equals negative 1/2, right? Let's take negative 1/2 and plug it in. Okay, I'm going to plug it in. I'm going to go, all right, I'm going to go negative with a negative 1/2 minus 4 times a negative 1/2 plus 5. I'm going to use my calculator. Heck yeah. Let my calculator do the work, okay? Let's see my calculator do the work. Oh, I'll shift it so you guys see. So I just plug the negative 1/2 in for x, right? And if I use my calculator, I'll show you when I get done what it is. Negative parentheses, I'm going to go negative 0.5, subtract 4, parentheses, parentheses, negative 0.5, plus 5, parentheses. So I get an answer of about 20.25. So it's way up there. So the best I can do is sketch in a graph that looks something like this. As long as you've got tomorrow, as long as you've got the correct x-intercepts, and you've got the vertex on the line of symmetry, I'll give it to you. You don't have to know the exact value of the vertex, okay? All right, number 8. Let's see what we got. So, number 8, we got x-intercepts, x equals -5, and x equals 6. Okay, so these came from many equations. That came from an x plus 5, and that came from an x minus 6. There we go. That came from an x plus 5, that came from an x minus 6, and there you go. If we wanted to FOIL it out, we could. X squared minus 6x plus 5x minus 30, or x squared minus 1x minus 30 equals y. But I will take, are you listening? I will take this answer or this answer, whichever one you want to give me. All right, let's look at number 9. Probably need to graph number 9, but I can do that. Remember, if I'm going too fast, just push pause and wait till you guys can wait until you're ready, and then the substitute can push play. Okay, just let her know at any time. All right, I'm going to go ahead and graph these points. So I've got a parabola. I've got a point at 0, 0. Got a point at 3, 4. 1, 2, 3, 4. And a point at 6, 0. 1, 2, 3, 4, 5, 6. All right. Sure looks like the parabola goes like this, right? All right, no problem. So here's what I know. My vertex is at 2, 4, nope, 3, my bad, 3, 4. It goes upside down, so I'm going to use my vertex form, okay? I'm going to go y equals negative parentheses x minus 3 squared. Remember, opposite plus 4. Okay, I know the negative because this has to go upside down. Okay, and I need my opposite 3 there and my 4 there. Okay, and that will work. All right, 10, we're getting there. Okay, so the best way to tell whether it's linear, exponential, or quadratic is basically just graph it, okay? I'm going to graph it. Let's see what 10 looks like. Okay, I've got -1, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 12. 1, 14. Ah, it's going off my page. Sure looks like it's straight, linear to me, doesn't it? Looks like it's going off my page. Huh, you should use higher graph paper. But it sure looks linear, doesn't it? Looks linear to me. So how about y equals mx plus b, which we learned in algebra, right? So let's go y equals a 1 over 1x plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 plus 11. Okay, that wasn't that bad. That was pretty easy. Oh, it must be 12. I think I made a mistake. That's got to be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's got to be 12. You know why I know it's 12? 0, 12. Oh, 0, 12. Okay. Goes up by 2s. Actually, I think I did make a mistake. Mr. Davies made a mistake. It's okay. Let me redo this, because I think this is supposed to be a 2 over 1. All right. Mr. Davies did make a mistake. Can't count. Let's try this again. All right. You want to see my mistake? Check it out. -1, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 12 is here. 1, 14 is here. So how about instead y equals a 2 over 1x plus 12. Wow. Sorry about the mistake. I knew I made a mistake though by that value there, 0, 12. I knew that had to be 12. Okay, that is the right answer. Sorry, I made a mistake. Okay, ready to turn the page to number 11? Flip the page. All right, number 11. Let's see what we got. Okay, let's graph it, see what happens. Number 11. 3 and 21. Wow, I'm never going to make that, am I? Hold on. May not even fit with the 21, but I'll try and get as many points as I can, okay? -1, 5. 1, got that. 0, 3, 1, 5, okay, 2, 11, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, and 321. Sure looks like a parabola to me. It does. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, this is definitely a parabola, and it's twice as tall. This is definitely a parabola. I can see this for sure. It's a parabola. So this is going to be a y equals a 2x squared plus 3, right? Starts at 3. There's my vertex at 3. It's twice as tall. Instead of 1, 1, it's 1, 2. That's where I got my 2. That wasn't so bad. Okay, number 12. All right, we're getting into our weird little things with the focus and the directrix. But we can do this, no problem. Okay, number 12. So the focus is at 0, negative 5, and the vertex is at 0, 0. Okay, let's graph it first, right? Let's graph it first. Alright, graph this. Okay, vertex 0, 0. And focus is 0, negative 5. 1, 2, 3, 4, 5. There's my focus. Okay, so here's what I know. It's a frowny face. Frowny face for sure. I know that P is equal to 5. 1, 2, 3, 4, 5. So P is 5. Okay, so now here's my equation. I've got to use the one that says y equals, and it's on the board, negative 1 over 4p, and I'm going to use my x minus h squared plus k. Now, 0, 0 is my vertex, so h and k are 0, okay? H and k are 0. So if I go y equals negative 1 over 4 times 5, x minus 0, which I don't need, plus 0, which I don't need. All right, so let's tidy this up. I'll have a y equals negative 1 over 20 x squared. That's all I need. And that'll make, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is my parabola. Okay, ta-da! Let's look at number 13. All right, 13. All right, we have a focus at 6, 0, and a directrix at x equals negative 6. Okay, if I can graph it, I can do it. Always. Always, always, always. If I can graph it, I can do it, okay? Let's see, I'll put that down. Okay. So if I have a focus at 6, 0, 1, 2, 3, 4, 5, 6, and a directrix at x equals negative 6, 1, 2, 3, 4, 5, 6. Okay, here's my directrix. My vertex has to be smack dab in the middle. Okay, has to. Has to be exactly between the two because it has to be equal distance to the focus and equal distance to directrix. Okay, now the darn thing goes this way, right? So we're going to use this equation. We're going to use x equals 1 over 4p, and at 0, 0, y squared. Okay, I don't need the other because I know that's 0, okay? P is 6, isn't it? P equals 6. So my equation is y equals 1 over 4 times 6 y squared. X equals 1/24 y squared. Okay, now to graph it, I don't even know if I have room. I gotta go 12 and 12 probably. 1, 2, 3, 4, 5, 6, 7, 8. No, it's just super wide. It's just not gonna fit. Made it too big. Anyway, there it is. Turn the page and we're almost done. Okay, turn the page and we're almost done. Okay, 14. Y equals 2 times x plus 5 squared minus 4. Okay, all we need is the vertex. It's in vertex form. The vertex is, remember, it is the opposite of that. It's going to be negative 5, negative 4. And we also know that the line of symmetry goes through the vertex, so the LOS, line of symmetry, is x equals negative 5. Don't even need to graph it. It's in vertex form. Opposite, negative 5, negative 4. Line of symmetry goes through the vertex, x equals negative 5. Okay? 15. Getting there. So, y equals 3x squared minus 24x plus 7. Okay, we have a b. We have a b. My b is negative 24. Anytime we have a b, we're going to have to use our negative b over 2a, which is going to be a negative 24 over 2, and a is 3. Okay, so let's see what we get. Negative 24 is a positive 24 over a 6, so we get 3. So our vertex is 3 something. X equals 3. Okay, so that's our line of symmetry for sure. Our LOS, our line of symmetry, is x equals 3. It goes right through there. Now what we don't know is the y value of the vertex. Okay, we've got 3 something, so let's plug the 3 in. Plug it in, 4x. Now I'm going to use my calculator, so I'm going to go, okay, y is equal to 3 times 3 squared minus 24 times 3 plus 7. Use my calculator, plug that in. Okay, I don't know if you guys can see this or not. Hopefully get the glare out of here. Just do it and then I'll show it to you, okay? So 3 parentheses 3 squared minus 24 times 3 plus 7. Okay, and I get negative 38. Y equals negative 38 when I plug it in. So I'll put my negative 38 here. So there's my vertex of my parabola. And there's my line of symmetry. Okay, we're getting done. Almost. 16, 17. A couple of easy story problems, okay? Alright, slide it over, and you can always pause it for number 16. Okay. Alright, water droplet falls after t seconds, falling from an icicle. How many seconds does the water hit the ground? So we have h of t equals negative 9.8 t squared plus 20. Alright, so when it hits the ground, the height is 0. When it hits the ground, the height is 0. Alright, so set it equals 0. Well, let's solve. Okay, minus 20 minus 20. Okay, negative 20 equals a negative 9.8 t squared. Okay, so I'm just solving. Just going to solve for t. Divide by negative 9.8. Divide by negative 9.8. So what is 20? I'm going to use my calculator. What is 20 divided by 9.8? Oh, it's about a 2.04. About a 2.04 equals t squared. How do I undo a t squared? Well, the opposite of t squared is square root it. Square root it, square root it. I use my calculator. I'm going to go square root of 2.208, blah, 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 blah. And I get about a 1.43 seconds. Okay. So what did I do? I set it equal to 0. I solved. Minus 20 minus 20. I divided by the negative 9.8, which made it a positive 2.4. I saw it at t squared, so I square rooted it, square rooted it, square rooted it. 2.04 is about 1.43 seconds. Last but not least, 17. Okay? So, in 17, we're going to throw a discus. But let's just draw a picture, okay? Let's draw a picture. It doesn't have to be a perfect picture, but it helps me if I draw a picture. Alright, the discus is started at 4 feet. I know from the equation it's 4 feet. It's h of t equals a negative 9.8 t squared plus 24t plus 4. Okay, I know it's going to go plunk, right? Now, let's see. First of all, describe domain and range. So domain, we don't have to find it, we just have to describe it. Domain is the time. Domain is always the x values. In this case, so it's the time the discus is in the air. Okay. The range, reach for your range, is simply the height of the discus. So the domain just describes time, because that's what this is time in the air. And the range, reach for your range, is the height that the discus goes in the air. Right, now almost done. So now how high does this fly? Well, that's right there, which makes it the vertex. So let's find the vertex. Okay, to find the vertex, we're going to use our negative b over 2a. I'm going to go negative 24 over 2 times a negative 9.8, which is I'm going to use my calculator. I'm going to go real quickly. What is negative 24 divided by parentheses 2 times a negative 9.8? Okay, see it in my calculator, and I get about 1.224. Okay, 1.22. We'll just say 1.22, or maybe how about 1.2? T equals about a 1.2. All right, so that's the time, but not the height. That's the time, but not the height. How do we get the height? Well, let's plug it in. So we'll go negative 9.8 times 1.2 squared plus 24 times 1.2 plus 4. Let me plug it in. Okay, so go negative 9.8 times 1.2 squared plus 24 times 1.2 plus 4. And I get about 18.7. About 18.7. We'll round it up. 18.68. About 18.7, and that's actually in terms of meters. All right, that's all I have. Good luck to you tomorrow. You can use your notes. You may use your notes.